Hello, we are discussing about GATE 1996 ECE paper, and this question is related to the microprocessors, that to address decoding. Look at the diagram. Consider the decoder circuit shown in the figure for providing chip select signals to an EPROM, RAM and I/O chip with 4 addressable registers from a demultiplexed 8085 address bus. A. Specify all the memory address ranges to which EPROM will respond. B. Specify all the memory addresses ranges to which RAM will respond. Specify all the I/O address ranges to which the I/O chip will respond. So what are the address ranges for each and every chip? There are 3 chips are going to be connected to the decoder. One is EPROM, the other is SRAM, the other is I/O chip. So what are the address ranges for those things for the given diagram that we are going to find? Okay. So first of all we should know about the operation of decoder. So decoder is going to be connected with 3 chips, but at a time only one chip can be enabled. So the enabling process is going to be depends on, okay, this is going to be decoder. It is going to be performing binary to decimal decoding, binary to decimal decoding, or binary to BCD. So here we are going for the binary to decimal decoding. The binary to decimal decoding is nothing but the information provided is going to be in terms of 3 bits. It is 3 to 8 decoder. So the information at input is consisting of 3 bits, and the bit whatever the bit combination, okay, whatever the bit combination you will give at the input side, that will be decoded into equivalent decimal number. That corresponding output line will be enabled and all other lines are going to be disabled. Okay, so let us assume if you want to enable 0th line, at that time the input combination present over here is nothing but 0 0 0, such that this is 0 is decimal and whose binary value is nothing but 0 0 0, so that it must be to select this 0. At that time, to select this 0, the inputs must be present at the decoder is nothing but 0 0 0. Similarly, if you want to select SRAM chip which is connected at the second input, okay, so to select this one, the input combination present for this one is nothing but binary equivalent of this line. So it is 2 binary equivalent in terms of 3 bits, so it is 0 1 0. So if you give 0 1 0 over here at that time, then second line is going to be enabled, all other lines are going to be disabled. That second line is connected to the chip select of SRAM, so SRAM will be selected. So similarly, if you want to go for the fifth line selection, fifth line implies nothing but 101 is going to be the combination, binary combination equivalent of 5. So if you give 101 at the input side, then fifth line is selected, that will be enabling this I/O chip. That is the meaning. Okay, so assume that one first EPROM is going to be enabled, okay, then we will go for the SRAM, then we will go for the I/O chip. Okay. So now, so first one is nothing but first case we will go with, let us assume that one, okay, 8k EPROM, 8 kilobytes EPROM is enabled, is selected. That implies nothing but the given input combination is 0 0 0, 0th line. So that implies nothing but IO by M bar must be equal to 0 and A14 is equal to 0 and A13 is also equal to 0. So whenever IO by M bar is equal to 0, A14 is equal to 0, A13 is equal to 0, the input combination presented decoder is 0 0 0. That is going to be decoded into equivalent decimal number, which is nothing but 0. So 0th line is going to be selected and that is connected to the chip select of EPROM. So that is going to be EPROM of 8 kilobytes is going to be enabled, and both are going to be active low signals. The output of decoder is active low and chip select is also active low. So this is going to be EPROM is going to be selected. Is that clear? And all others are going to be disabled, so that SRAM and I/O chip are going to be not selected. By that time, now we have to specify what is the address range. Okay, so address range for this one. So the 8085 address bus consisting of 6 bits and 16 bit address bus. so that we can write like this: A15, A14 and A13, A12. Okay, and what was given is nothing but it will be consisting of 8 kilobytes. 8k implies nothing but 2 power 13. 2 power 13 implies nothing but 13 address lines it requires. So 8k requires 13 address lines. 13 address lines. 13 address lines is nothing but we can go for the A0 to A12 are going to be the address lines used. So EPROM is going to be used with A0 to A12 address lines. Okay, so this is first MSB we are going with this one, and later we are going for the A11 to A8, next A7 to A4, next okay A3 to A0. So this is what we are going in this way. So out of this one all are going to be here. This is A0 to A12 is the address lines for the EPROM. So the minimum value is nothing but the starting address location is nothing but all are zeros. So this is 0000 and this is also 0000. This is 0000. This is starting memory location, and ending memory location is nothing but all ones. So this is what all ones is nothing but ending memory location. Okay, now we have to specify A13, A14. A13 is equal to 0, A14 is equal to 0. So then only this EPROM is going to be selected, and A15 implies nothing but it is not specified in the diagram, so it can be don't care. Okay, so this is what the range. So by assuming since A15 can be anything, so assume that one A15 is equal to 0, then the range can be specified like this. We will go with this assumption for all the things A15 is equal to 0. Okay, so by assuming A15 is equal to 0, we can specify the range. We can specify the range as this is 0000 will become, and it is 000. So you are going to be getting 0000 is going to be first hexadecimal location, and ending is nothing but last hexadecimal location is nothing but 0001, that is 1, and FFF you will get it as. So the final location is nothing but F1 FFF 0001. This will be higher nibble is going to be giving 1, and all three lower nibbles will give the F. So that this is what 1FFF is going to be the memory locations for the 8K EPROM whenever it is selected. Okay, similarly we will go for the other two things also. Second one, this is what the second diagram, and here SRAM, again it is going to be 8K SRAM only, even though it is given as 8 into 8, it is 8K in the problem. So this is 8K, again it is 8K into 8. So 8K into 8 is nothing but 8 kilobyte of SRAM is selected. Okay, 8 kilobytes of SRAM is nothing but again it is going to be 2 power 13, which implies nothing but 13 address lines it requires. 13 address lines. 13 address lines it requires, and that implies nothing but A0 to A12 are going to be the address lines to be used, and 8K SRAM is selected. 8K SRAM is going to be selected. It is connected to the second line. Second line implies nothing but this is 2 is decimal number whose equivalent binary is 010. That implies nothing but it has to be 010. So A14 is equal to 0 is selected when A14 is equal to 1 and A13 is equal to 0 and IO by M bar is equal to 0. So whenever the situation is going to be given in this way, that is IO by M bar is 0, A14 is 1, A13 is 0, at that time 8K SRAM is selected, and to specify the address location it requires 13 address lines because it has 8 kilobytes. Okay, 8 kilobytes is nothing but it requires 13 address lines, that is nothing but A0 to A12, and the address range can be written like this. This is A15, A14, A13 and A12. This is higher nibble, and lower nibbles implies nothing but A11 to A8, and next lower nibble is nothing but A7 to A4, next lower nibble is nothing but A3 to A0. Okay, so starting address can be written like this. Starting address starting address whenever it is selected at that time it is requires 13 address lines. So these are A0 to A12. Starting address lines is nothing but all must be zeros, zeroth location. So this is starting address location. Ending address location, ending address location, ending address locations is nothing but all ones, all must be ones. This is the ending address location for the 8K memory. Next, A13, A14. A13 is 0, A14 is 1, so that it can be written as 1 0, and this can be written as 1 0. A15 is not specified in the diagram, so that it can be treated as don't cares. Okay, so assume A15 is equal to 0. To write the range, assume A15 is equal to 0, then range of address, then range of address can be written as starting address. Starting address is nothing but now x is replaced with 0, so this is 0100, which is nothing but 4. Okay, and all other nibbles are going to be 000h to this is 0101, which is nothing but 5, and it is FFF, so 5 FFF. This is address range for the SRAM. And next, third one is nothing but, okay, this is IO by IO chip. IO chip is going to be connected to fifth line. Okay, fifth line implies nothing but the equivalent decimal binary number is 101, so that you must give IO by M bar. This is IO by M bar is equal to 1, and A14 is equal to 0, and A13 is equal to 1. Then 101 combination is nothing but equivalent decimal value is 5, so that fifth line is selected, and this is going to be enabling the IO chip. Okay, so IO chip is going to be consisting of only two lines, A0 and A1, even though it is dotted, dots are going to be indicated. Okay, it consisting of only two lines, A0 and A1, so only two input lines, only two input lines it consisting of. Actually the dot should be present over here. Okay, so only two input lines, so this is third one we are going with. So IO chip is selected, IO chip is selected when A14 is equal to 0, A13 is equal to 1, and IO by M bar is equal to 1. So IO by M bar is equal to 1 is nothing but now input output, that is IO devices are going to be enabled. Whenever it is 0, that is related to the memories, so that SRAM and EPROM is going to be enabled. Whenever IO is equal to 1, it is going to be enabling the IO chip. So that now the range can be specified like this: A15, A14, okay, A13, A12, and next A8 to, okay, sorry, A11 to A8, A11 to A8. This is higher nibble, this is second higher nibble, and third higher nibble is nothing but A7 to A4. Fourth higher nibble is nothing but A3 to A0. So this is 16-bit address bus for the 8085, and we are going for the starting address. Starting address implies nothing but simply it consisting of only two lines. Two lines implies nothing but A0 A1. So we will write it as in a better way like this. Here we are going with only two lines. Those two lines I am going in this way. Those two lines I can write it as A2 A1 A0. Okay, so A1 A0 are going to be the actual lines, so that they will be zeros for the starting address, and for the ending address, since it has only two input lines, those two must be ones for ending address. Okay, and others are going to be don't cares except for A14 and A13. A14 is going to be 0, and A13 is equal to 1. A14 0, A13 1. Whenever this is taking place with IO by M bar is equal to 1, then only IO chip is going to be selected. This is very very important. IO by M bar has to be 1, then only this IO chip is enabled. By that time A14 is equal to 0, A13 is equal to 1, and all others are going to be treated as don't cares. So this A12 is also don't care in this case. All are going to be don't cares. This nibble is also don't cares. Okay, so this nibble is also don't cares. and A3 A2 is also don't cares. So assume don't cares as 0. Assume don't cares. Assume don't cares as zeros. Previously what we have seen is nothing but A15 is don't care, so that A15 is assumed as 0. So here it is, the whatever the don't cares are going to be assumed as 0, so that the range of address, the range of address for IO chip is so this is 0 0, all zeros, x will be replaced with zeros, so 0 0 1 0 is nothing but 2. Okay, so this is 2, and second higher nibble is 0, third higher nibble is 0, and last one is also 0. 2000 H2, this is again 2003H with, remember that one, with IO by M bar has to be equal to 1. So this is nothing but address range for the IO chip, and address range for the SRAM is 4000 to 5FFF, and address range for the 8K EPROM is 0000 to 1FFFF. So these are going to be the address ranges for the given chips. Thank you.